Okay, so thank everybody for joining today. I'm Daryl Price. I've got with me George Williams and Kyle Akers. We represent a part of the sales and design automation group within our enterprise services team. And today is the first of a three-part series. We're going to be focusing on automate your drawings. And we're focusing really on workflows. How does data come in? How do we streamline that? And at the end of the day, how do you leverage technology where it makes sense? And the focus today is that drawing output. If we're dialing in on where we're focusing, it's really on the engineered to order and configured to order areas. So this is not the fit that we would be looking for a made to stock type product. So we're looking for drawings that need to be project or product specific in the moment. So with that, I'll go ahead and turn this over to George. George, I'm going to make you presenter. You're on.
All right, good. So a quick introduction about myself and kind of the perspective that the D3 automation team brings to these projects. I'm an engineer. I come from industry. I've been with D3 12 years, but prior to that, I was with a company called High Troll Conveyor Company, and I was director of engineering and product technology there. And so we implemented quite a few automation projects over the years, and so we always take a perspective of it can be possible, but it has to be practical as well. And so when we talk about platforms, and that's what Ruler is in the three-part series, we'll talk about each component of the platform. Our goal is really to make possible become practical so that mere mortals like myself can go and implement these tools using your business logic, company's business logic, and you don't have to be a seasoned programmer and understand everything there is to know about the depths of the Inventor API. If any of you on the call have had any experience in that, you know that bare metal access is pretty powerful stuff, but it may be a little impractical because when you really start getting down into the depths of it, you start to develop some patterns like I'm redoing this all the time, but I don't like typing all this code, just to add a dimension or just to add a view. There's got to be an easier way. So whenever you have that do what now moment of why am I doing all this, that's where we have come in, and we try to make the when we hear the do what now, we want to come in and codify that so that it's easy. So our goal is to simplify Inventor automation across the board. And the platform that we'll be talking about in this series is the Ruler platform. We have three components: Ruler Config, Ruler Model, and Ruler Draw. And the whole point of that is to get you most of the way there, right? To give you a good foundation to build upon so that you can be successful. You can use the rest of that progress bar there on the right to fill in your specific rules and quit worrying about the bare metal access because you can do it. We're all smart people, we can do it. But the question is, why am I doing this? I need to be doing, implementing my business logic on your projects. Okay, so enough of the preaching. Let's get into a quick demo here. And so I'm going to show you the end-to-end, but we're going to focus on the drawings. And so this is our vessel configurator. This is running on Azure, the Microsoft Cloud. And so we're going to go into a new project here. And this is not a presentation about pressure vessels, but we've got to have some content to show. And so I'll quickly import a compress. It's an analysis file for that industry. And so I've read that in. And I've got everything about the costing, et cetera. Talk about that in the upcoming webcast, but right now we're interested in getting the CAD outputs. And so these are real-time, lightweight graphics. That is not Inventor. That's 3JS done in real time. So we're going to queue the CAD outputs. I'm going to push this button. It's going to go to Autodesk Forge with the Inventor Design Automation API. And so we've queued it up. And so we go to the project page and we see that the job is processing. And so it's going to take a few moments here to go through all that and create a model and create the drawing. That's going to create what's called an SVF so that we can view this thing on the web. It's doing all that off on an Autodesk server somewhere. And just as a piece of information while this is running about Forge, I could load this up with 20 vessels and it would do them all in parallel, where this may take a minute or two to run rather than waiting, 40 minutes for them all to run. I can get all 20 of them in 2 minutes. So that's really the benefit of Forge Plus. You don't have to maintain a seat of Inventor on your local system. And so it's giving us feedback. It's saying, yes, I'm making the drawings now, and it'll take just a few moments to make that. And we'll go over and take a look at what was created. So it's processing that guy. When we get done with the drawing, it'll create the SVF for the drawing. Like any good cooking show, we already had a couple in the oven ready to come out. So let's just take a look at that. Let's take a look at the model. And again, this is not the focus of this presentation, but this is a real inventor model that was just created from that simplified set of graphics in the analysis file that we imported from Compress. And so we have to have the model, as you know, in Inventor to get the drawing. And so let's take a peek and make sure, yep, we're all done. And so I'm going to come over here and take a look at our drawing now. And this is a simplified drawing because Forge is still in beta on the Inventor API. But some interesting things to note here is that it did this in, I don't know, less than 2 minutes. And if I send any vessel over with any number of nozzles on the head or the bottom or the side in any location, Ruler Draw will create the dimensions for them. And we're going to show you how it does that in much less code than you would have to do in something like iLogic. So it's a pretty generic solution that you can use to create very custom drawings. And we've got some examples that we're going to show here in a moment with really, really complex drawings that we're able to create using this markup language. Okay, so now we're going to pop back over to our presentation and we're going to talk about what the heck just happened. And so we're using the configurator, the vessel configurator, that's ruler config. And ruler config said when I pushed the button, it sent over the data file to ruler model using Forge, which also can run Inventor if you have an on-prem requirement. And so when it was done with that, it sent it to the last piece, which is ruler draw. And ruler draw said, hey, I have a model. I'm going to go to Forge. I'm going to go for Inventor on-prem, and I'm going to create the drawing outputs. And so today's webinar is focused on the ruler draw piece, but the takeaway here is each of these can be daisy chained together, or they can be run independently. And so that, in software terms, that's called loosely coupling it. And so we keep it loose to keep it limber so that we can automate the models, we can automate the drawings, and we can do both if you want. And that's exactly what we just showed right now. And so this allows you to choose your own adventure. And so again, you can create the models and go to model output and you're out, you're done. Or you can have your own solution piped into the modeler, create the models, and you're done. Or you can say, all right, I want to continue on this adventure and create the drawings, and then I'm done. Or you can, again, pipe in your own solution, just straight to the draw, ruler draw, and then you create the drawings at the end. So it's a very modular solution that you can use for whatever your requirements are. And so any Inventor model will do. Human-made, Excel, iLogic, spawned from a Vault job handler, ruler model, or some really cool automation that we don't even know about yet. Whatever gives us an Inventor model and it has literally one iProperty in it that says, give me the drawing markup. And so we'll show you what the drawing markup here, what the drawing markup is in just a moment, but it abstracts the Inventor API, and that's just a fancy way to say it puts Inventor in a box, and it's just saying, here are the things that we care about, and all that complex, deep Inventor API is hidden from you because, quite honestly, you don't care. You just want to create dimensions or create views. And it uses C# scripting, and so hopefully you didn't fall out of your chair when you see that word C#, but it's really simple on what we're able to do in this markup language, and I'll show you that here in a moment as well. And of course, it's brought to you by Ruler. It's part of the Ruler platform. And you can access all components, parameters, and properties in the Inventor model. Essentially, we can also, since we give you all those components and properties that in the Ruler drawing library, you can inherit and extend it and make it very specific for your own needs. And so the big idea here that we've had, and we've had quite a bit of success with this, drawings are to models as reports are to databases. And so what we're trying to get at here is the big idea we had was, okay, if you want to get a report on a database, what stands between the report and the database model is some schema, some markup. And so we said, well, why don't we do the same thing with drawings? And drawings are just an output of some model data. And in inventor speak, it's literally a model. And so that's what we did. We put that between the model and the drawing to just define what that report is going to look like. And so we say that one markup rules them all, right? So we can have a very generic markup that can create very specific drawings. And so we take any model, the drawing markup, and we produce the drawing on the other side. And so for the example that you just saw, we take this model and we're creating this drawing. And so what stands between is the markup language. And so I hope you have your seatbelt on. It's a little codey. Hope you don't fall out of your chair too much, but at some point you got to tell the computer what to do, right? And so we work really hard on making that simplified. And so if you get around the decoration here, let's just peel it apart and see what we're really doing. We're saying we want a sheet. We want this border, this title block, and we have this concept of a box where we put a view in a box so that we can nest views together and make sure that annotations don't fall out of that box, and it's literally a bounding box around the view. And so within that view, we say we're going to create a vertical dimension for every component in the dimension components group, and then we have this little property in our model called right vertical dimensions, and it knows all the dimensions on the right side and all the dimensions on the left side. There may be 0. And if so, then it doesn't create any vertical dimensions over there. But you see what it's doing here is it's saying, all right, it's just a simple loop for each. And this is the C# scripting I'm talking about. You don't have to be a computer scientist to write this. We have a very well-defined format and well-defined help files to help you through this. And so at the end of the day, we've got 1, 2, 3 vertical dimension objects that can create any and all of these, depending on the configuration that's sent over to it. It looks at the model data and says, I'm going to go create all these things. And so in just 34 lines of code with some white space between, I can take any compressed file and create what they call a sales sketch type, pre-buy type drawing, where it just gives overall dimensions on these locations. And it's very fast. It gives them a head start. And within 2 minutes, they can have drawings sent out to their customers, which is pretty powerful. And like I mentioned, we have an extensive help guide on how to do these things. And so if you want to come in and say, all right, I want to know how I do the box that we just talked about. Well, there's a box, there's a little snippet for that. How do I do a dimension? Linear, angular dimensions, fine. So any of these, we give you snippets that you can come through and create your dimensions by just using our help file. And we like to include lots of examples in here so that you're able to just copy and paste those. And we also include a number of release notes that you see what we're doing and how we're improving the product and the new features that are available within it. Okay, so moving on to, why don't you just use iLogic? It's probably a thought that's in your mind. Well, those that have used iLogic, I would say you probably haven't had the most pleasant experience with drawing automation, because it seems like that's where iLogic stopped, that they really didn't complete the task of automating Inventor, because this is what you get when you start, this is what you have to do when you start automating drawings in iLogic. And so this is iLogic code for one dimension versus that ruler markup for all those dimensions, an unknown number of dimensions. This is very specific. It has to know where I'm going and what I'm doing. And so, I can do this. You could do this. If not, you probably do it, right? It's readable. It's not alien technology, but you got to ask yourself the question, why? And definitely when you look at this, I have the reaction of, do what now? Why am I going to be doing this when I can come over here and just concentrate on the content and not worry about what goes into actually making a vertical dimension or actually making the sheet. This doesn't even say anything about the sheet. Over here, we just said one line, create a sheet. And all that stuff that creates the sheet is done automatically. It was kind of funny to us. We went to AU and we saw an iLogic class where they said, hey, we're going to create this sheet. And it was literally 20 lines of code. And we're just kind of chuckling to ourselves because ours behind the scenes is 20 lines of code, but I want to do that every time. So we have that abstracted away, and you just say, here's a sheet, there's the properties on it, and there's where I want to put it. And if you want more properties for that sheet, then you can certainly come back over to this view and look up, what's all available for, the drawing. As an example, what are all the attributes that I can put in there for that guy? Okay, so moving on, we're going to do more demo time here, and this one's going to be a live example of that same project, not running on the cloud, not running on Autodesk Forge. It's going to be running on Kyle Akers' machine, and it'll produce a more detailed Inventor drawing because it's not in beta, it's real Inventor. And so Daryl, maybe I can change the presenter here. Yes, I will change it to Kyle, and we'll move over to him now.
All right, let's see which one it has me showing. Did my computer just freeze? All right, am I showing a screen?
The job processor.
Great. Okay, I have just off screen here the vessel configurator running live on my machine. So I'm going to just hit that same QCAD outputs that George had pressed, and we can watch as our job processor grabs the job and starts working. You can see the full output folder below where everything's going to end up is totally empty. So we can watch in real time as Inventor gets spun up, the models get generated, and then the drawing gets generated. And when that's complete, I'll open that up and you can see what all we did for this significantly more involved drawing compared to that previous one.
Now, Ruler Draw is available as an add-in to Inventor. So if you don't want to run it in a server application like this, we do have the ability that you can run it. You can run that XML from inside of Inventor as an add-in. And we have customers that are doing just that because they don't have a need to have it live on some separate server, but they don't want to. But again, you're working in that XML defining these reports on your drawings. Okay, so now it's running with the drawing, and it's created all the components for that model as fast as it could push electrons through the box.
And you can watch here as it creates every individual piece of this drawing, the views, each linear dimension, the title block, all of that.
So it's marching down through that XML, and now it's done. And so you can just bring that up in Inventor View or Inventor, either one, whichever one you want to do. Since Inventor 2018 is not in beta, we have a real Inventor drawing that comes out of it, as if it were created by a human. There we go. And again, like we mentioned earlier, any vessel that we send over would have various annotations on it for this particular configuration. Let's move back to my presentation now. Just wanted to show you an example of it running inside of Inventor and not just on Forge. All right, I'm going to make me the presenter, showing my screen, and I assume I'm on more demo time.
You are?
All right, and so marching through that. So we showed the example of the pressure vessel with all dynamic dimensions. Well, we have another concept that we think is pretty powerful. It's called the factory drawing to the member drawing. And so many customers have these drawings that are not to scale, or they've got charts, massive charts for the different sizes, and it says dim A, dim B, et cetera, et cetera. And so the trouble with those, in my experience, when it gets out to the shop and it's greasy and low lit and everything else, and you've got those people on the shop floor trying to look on a chart and figure out what dimension A is for this particular configuration, and it's putting a lot of pressure on them. And so what if you could have it so that it creates this only the view on what you need? Well, wouldn't that be great? But as you look at that, what it takes to create those drawings, you may step back and say, my gosh, it's just not worth the effort because there's so much coding out there. I'll just put the chart on it and move on because it's easier on me, Mr. Engineer, and everything's about me, right? Well, let's make it easy on the shop. And so that's what we've done here. We've got this simple mode where we can take this factory drawing and just put text in where the dimensions are. And we can say when it configures the specific component, we can look, we have a special tag in our ruler markup that says, go look for the text pattern beam length on any annotation and replace it. This double bracket is C# scripting again. This double bracket means an inventor parameter named length. Go find the inventor parameter named length and pipe that value into that dimension. So we create the very specific drawing. And so now, instead of having charted drawings, we can have specific one-to-one configuration to drawing. And so on the shop floor, it says, here's the shop order number, here's the configuration, here's the drawing with all the dimensions on it. And it's all spawned from this generic factory drawing. And just a little side note here, our XML markup, the double parentheses means an inventor property, and the double brackets means an inventor model parameter. And so with that, we can do quite a bit of stuff. And so with just these 5 lines of code, I'm able to make a very specific drawing off this generic. And this is very practical. You can really take advantage of this on very complex drawings because you're basically just overriding the dimensions. And I just wanted to wrap up here with some examples of various systems. This is a storage rack system, huge layouts, 600,000 square foot facilities that these are going into, where our ruler drawing XML can go in and say, for every unique configuration, for every unique elevation, create a new sheet with the front view and the side view over and over again. So it can look through all 600,000 square feet, find all the unique elevations and create drawing sheets for that, because that's really what they want. The unique elevations. This one is for, they make these posts that you see at the airport that are wrapping these columns with, cladding or basically just panels around there. Extremely configurable. And so this is everything on this view was done dynamically with the ruler draw XML markup. And then we go into a conveyor example. They actually wanted it to go to AutoCAD at the end, so we took it to Inventor, then convert over to AutoCAD at the very end of the process. But everything that's done on both of these views done completely dynamically. And if you have a configuration with multiple panels here, many different sizes, it will continue to add panels and spill over to another sheet and just continue to add unique panels as it needs to. So again, this is something they were doing manually. Now it's just run automatically through ruler draw. This is a very complex example of a heat exchanger, and it can go through and create the top level view, and then also all the layers that go into this heat exchanger, all the unique ones, and annotate them with the correct bubbles, and on and on and on. And so everything that you see here was done with the ruler draw markup. So I wanted to show you that it can get extremely complex in terms of what it's producing. But if you remember what we said with the vessel example and the nozzles, we're just saying, give me all the nozzles that are on this side and start dimensioning them and just offsetting them. And so this is literally one horizontal left dimension node, and this is another one, but it can create all 5, 6 of these dimensions, all 5, 6 of those dimensions, and then one more creates all of these. And there may be more, we don't know. These are just snowflakes that come through on all the different nozzles that they have on there. So, it can work with iLogic as well, because this table is created with iLogic after ruler draw is done creating the rest of the model. So you can use things where they make sense, but it's very extensible in that way. Okay, so wrapping up here, putting it all together, platforms make possible become practical. And we say, build the solutions on shoulders of others. We're here. We've done these things. We've got the scars to prove it, right? So build on the shoulders of us. Choose your own adventure. Loosely coupled solutions are very agile solutions as you look for a solution set to your problem. And where do you go from here? You can do it. Number one, you can make it happen. So just get moving, just get going. And the big question is build versus buy. We think we offer quite a bit of value in what we've developed here. And so we would say, okay, buy. And then you go focus on your specific logic. And as always, we're here to help. providing modularity and a cross-pollination. We've seen a lot of ways to do things, and some aren't quite the best, and some are really cool in our experience working with various companies over the years. And so that's just a service as part of what we do. Okay, so I'll leave it here and I'll let Daryl wrap up with some thoughts.
Yeah, thanks, George and Kyle. And one of the things to keep in mind when you look at what we're doing here, it's very CAD neutral. I know we speak a lot about Ford, we speak a lot about Inventor, but when we start calling out and making these calls to the modeling engine, we're doing solutions that call to SolidWorks, and we've got other tools that we're making calls to as well. So it's really, it's a CAD neutral approach to get drawings out. And it's something that, you know, leverage it to scale where you need the help. Next week, we're going to be talking about automate design and sales estimates. So it's how do you provide the user interface for your teams to be able to pull these solutions together so you can automate from the front end. It's just instead of just automating at the back end. So please join us and look forward to speaking to you then. Thank you all.